Welcome back, Wisdomers. In this session, we will develop a foundational intuition for hyperplanes. Mastering the geometric and mathematical principles of hyperplanes is critical, as they form the essential building blocks for understanding linear classification, support vector machines, and the broader architectures within machine learning and deep learning. In the end of the video, don't miss our quiz challenge. Let's first examine the slope-intercept form of a linear equation, y equals mx plus c. In this framework, m represents the slope, which defines the steepness, while c denotes the y-intercept, indicating the point where the line crosses the vertical axis. Now, to illustrate this, consider the equation y equals 2x plus 3. Here, the slope is 2 and the intercept is 3. Let's observe how this relationship is visualized within a two-dimensional coordinate system. Now, let's explore the dynamic nature of this equation by adjusting its slope. Observe what happens as we increase the value of m from 2 to 5. As the slope increases, notice how the line becomes significantly steeper, climbing more rapidly across the coordinate system. Similarly, watch the transition as we shift the slope from a positive 2 to a negative 2. This shift not only alters the slantness, but entirely reverses the direction of the line, demonstrating how a negative slope creates a descending relationship. Next, let's analyze the impact of the y-intercept on the spatial position of the line. Using our equation, y equals 2x plus 3, we will observe the effect of adjusting the intercept from 3 to 5. This results in a vertical translation, where the line shifts upward while maintaining a constant slope. Furthermore, we will examine the transition as the intercept shifts from 5 to negative 5, demonstrating how the intercept dictates the line's vertical change, without altering its steepness. As we have demonstrated, any line can be positioned anywhere within a two-dimensional coordinate system by simply manipulating the slope and the intercept. Now that we have established this core foundation in 2D, let us extend these geometric principles to visualize a plane within a three-dimensional space. If you find this content valuable, please consider sharing and subscribing for more technical sessions. You can also visit wisdomers.in to access interactive quizzes and hands-on projects. Now, let's move forward with the lecture. We will now extend our geometric intuition to the three-dimensional coordinate system and the mathematical representation of planes. The general equation of a plane is defined as ax plus by plus cz plus d equals 0. Now, by isolating the z variable and rearranging the terms, we can express this relationship as z equals m1x plus m2y plus m0. In this form, m1 and m2 represent the slopes relative to the x and y axis, while m0 serves as the intercept on the z-axis. Let's analyze the dynamics of a three-dimensional plane using the equation z equals 0.1x plus 0.2y plus 1. We will first adjust the slope m1 from 0.1 to 0.5 to observe how the plane changes along the x-axis. Next, we will transition the slope m2 from 0.2 to negative 0.6, demonstrating a shift in the plane's orientation relative to the y-axis. Finally, we will modify the intercept m0 from 1 to negative 2, illustrating a vertical translation of the entire surface while preserving its multi-axial slopes. Having established a solid geometric foundation for planes in 3 dimensions, we can now generalize these concepts to higher dimensional spaces. In a 4-dimensional coordinate system, a plane is expressed by the equation m1x plus m2y plus m3z plus m4p plus m0 equals 0. It is a fundamental principle in mathematics and data science that any linear plane existing in a space higher than 3 dimensions is formally defined as a hyperplane. I hope this session has provided you with a clear and intuitive understanding of how these planes function across multiple dimensions. Thank you for your focused attention throughout this session. To consolidate your understanding of hyperplane intuition, we have prepared 2 logical challenges for you. Now, we encourage you to analyze these problems carefully and share your solutions along with your reasoning in the comment section below.